Welcome to Pure Aqua's Learning Center. In this series of videos, we will cover top-mounted control valve. This particular video will go over the Fleck 3150 valve, which is manufactured by Pentair. We'll cover 5 main points, starting with the valve specifications, installation, programming, troubleshooting, service and rebuild kits. In this section of the video, we will cover the valve specifications. Pure Aqua has chosen the Fleck 3150 valve because of its high performance, extreme reliability, and cost effectiveness. The valve can handle flow rates up to 95 gallons per minute for the service and backwash flow rates of up to 105 gallons a minute. This allows the valve to be installed on maximum size tanks of 42 inches in diameter. The valve comes equipped with a fully adjustable 3 or 5 cycle control and comes optioned with 3 different types of controllers: an NXT controller, an XT controller, and an electromechanical controller. The valve out of the box comes equipped as shown. We have our front cover here, our NXT controller here on the right hand side. Moving on to the back of the valve, we have our 3 main connection points. We have our inlet, outlet on the left side with respect to the valve from the back, and our drain on the top. And just to note, the drain here is missing a drain line flow control, which we will go over shortly. And one last point, we have our electrical power connection, which goes through the strain relief here, which we will discuss later on. In this section of the video, we will cover the Fleck 3150 valve installation. The steps discussed will be what are needed to get this valve installed and online and operational. Starting from the left hand side here, we have our Fleck 3150 valve body, of course with the controller, 2-inch inlet and outlet connections, our 2-inch drain line flow control, 2-inch distributor screen, the 2 screws that hold the distributor screen in place, 220-volt transformer, lubricant, and generic laterals and riser pipes. Step 1 of the installation process will be installing the drain line flow control onto the drain connection here. As you can see, the drain is clearly marked with drain, and that is on the top part of the valve. Now, what's shown here is a 75 gallon per minute of flow control. However, the specific flow rate varies based on application, tank diameter, and media type. So for the sake of this video, we're using a 75 gallon per minute, and it's very important to match the flow direction with what's marked on this flow control. So of course, since the drain water is coming out of the valve, we would need to install the flow control in that same direction. So once Teflon paste or Teflon sealant is installed onto this thread, this gets installed here, initially by hand, and of course finally tightened with some kind of wrench. The next step will be installing the distributor screen onto the bottom of the valve. We have the valve flipped upside down now for demonstration purposes, which makes the valve easier to work on as well. So we actually recommend flipping the valve, setting on a worktop station, and following the steps we're about to do. So first would be to install the distributor screen here and allow it to clip into place. And once you hear that clicking, you know that the valve has been securely installed. As mentioned before, we have 2 small screws. They're stainless steel, flathead, and these screws hold the distributor screen in place. Since this is now a larger valve, it requires some kind of screws to hold the screen in place. A small pilot hole will need to be drilled just to make it easier to install these screws. Now, it's very important that your drill bit is smaller than the screw, so for the sake of this demonstration, we're using a 5/64 drill bit again, but it's very important you double check and make sure that the drill bit used is smaller than that of the screw supplied. So once that's done, make a small hole here just for the sake of making it a little bit easier to install this screw. Once that's complete, the screw gets installed here on both sides. There's 2 screws, one here shown and one directly on the opposite side. So step 3 of the installation process will be installing the transformer onto the control board and making sure that's wired correctly. Now, before we even begin, we want to point out that it is very important that the valve is safe to operate and safe to work with at this stage of the installation process. Make sure that the transformer is not connected to the wall, as injury can occur.
Now again, just to remind the viewers here, various transformers can be used. This is a 220 volt or 230 volt. 110 volt does exist based on, of course, the local power needed. Now here, this end of the transformer, or this pigtail with the stripped wires, get installed onto the control board. So initially you would want to route the wires through the strain relief, and of course at a later stage these all can be zip tied nicely, just to make sure all the wire is routed properly, and they will get installed onto the control board, which we'll go over shortly here. Once that's all done, you would want to tie in the strain relief to make sure that the wire cannot move back and forth, which is a safety concern as well. So once that's done, this gets tightened, the wire cannot be pulled, which is very important. The next step of this process would be to install these 2 wire leads onto the correct place here on the control board. It's very important to note that there's many different places where customers typically think this 24 volt gets installed. However, there's only one location that this gets installed. On the bottom right hand corner here of this control board, there is a place that's marked 24 volt. So once that position is located here where my finger is pointing, you have 2 small pins here that get pushed up, and the wires get positioned right into place. So once that's done and the valve or the wiring is installed onto the valve, it's important to kind of pull on these wires to make sure that they've been securely fastened, just to ensure that there's no damage that can occur here in case the wire is actually not installed correctly. Once that's verified, that completes the installation of the transformer. Something to point out here, these transformers can be kind of installed on a wall. This really varies or depends on the on-site conditions, but that's just something here. There's tabs here where this transformer can get installed on a skid or some kind of wall. Step 4 of the installation process here would involve lubricating 2 different O-rings. There's the inner O-ring here where the riser pipe gets inserted, and the outer O-ring that seals the tank and valve together. Pure Aqua recommends using a Dow 1-1 lubricant here, which is just a general purpose silicone based lubricant. Just for the sake of demonstration, we want to show what happens when the valve gets inserted onto this riser pipe on the tank. So essentially, of course, the pipe gets pushed down onto the riser pipe and gets securely installed. So just a few things to point out that are not related really to the valve installation. Of course, you have your FRP tank or any other type of tank that's used in the application. You have your distributor laterals on the bottom that get installed with some kind of riser pipe, and once that's done, of course, the media is loaded inside the tank, and that happens before the valve gets installed. So for the sake of demonstration, of course, the riser pipe will be sitting dead center onto the tank and should be typically flush or slightly less than the top of the tank. The last step here of the valve installation would be to, of course, to install the valve onto the top of the tank. We've made sure that our media has been loaded, and of course the distributors and all screens and laterals are safely installed, and our riser pipe is centered up, and the valve gets installed onto the center. And something to point out here, typically these metal valves get installed in these FRP tanks with plastic fittings here on the top. So it's very important to make sure that your valve is straight so you don't really cross thread any part of the tank here, as that's typically a problem that can happen. Once that's done, the valve, it's only hand tight, and once you get to the point where the valve is somewhat snug, you go to about another 1/4 to 1/2 turn, and with that the valve has been completely installed onto the FRP tank. Step 3 of the tutorial video will cover the programming. Now, since this valve has an NXT controller, we will refer you to our Fleck 2850 NXT controller video, which covers the same exact points except for one setting, which is indicating that the valve is a 3150 valve and not a 2850 valve. Section 3 of the tutorial video will cover the programming instructions for the 3200 NXT controller. So just kind of looking at the front side of the controller here, we have a 2-line display which has various status or indications that we'll go through shortly. You have 5 buttons. Starting from the left side, we have our diagnostic button, we have our extra cycle button, we have our shift button, down and up arrows. So the purpose of the diagnostic button will allow the operator to view flow rates, to view totalizing capacities and hours between the last generations. The extra cycle button cues a regeneration,
or can also move on to the next step during the programming steps. The left button here allows the operator to, I guess, select a different character or line when programming the valve, and the up and down, of course, can change the values. So step one of the programming section here would be to set the local time. So our local time is right around 12:15 p.m. So to do so, you use the up and down arrows just to toggle with the setting of time. So for example, I want to increase the time, so I can just hold the up arrow for about 3 or 5 seconds, and that will get you into a set time of day section here. So to do so, of course, it's very straightforward. So to set the local, to adjust the minutes, you know, I can hold the down arrow or up arrow just to toggle with that. If I want to change the hours, I use the shift button to get me to the correct, I guess, character I want to modify. So again, our local time is 12:15, and that's what the time has been set at. Now to exit that, I can just press the extra cycle button for 1 second, and that gets me back into, I guess, the home display. So the Fleck 3200 NXT controller has two different types of setting menus. We have our master programming mode and our user programming mode. The master programming mode is a much more sophisticated or customizable programming mode where every parameter of the valve can be set, from backwash lengths to different types of outputs and inputs. The user programming mode is a simpler, less sophisticated programming mode where a lot less of the valve settings can be customized. It's really geared towards operators where just certain set points can be modified, so they're not really playing around or changing very important set points of the valve controller. So to access the master programming mode, two buttons must be pressed. You have your shift button and the up button. Those must be pressed simultaneously for right around 5 to 7 seconds. And once you enter the master programming mode, the first setting will be changing the language. So the default is English. You know, you can toggle through various languages like Spanish or Portuguese and so on. So we will of course keep it set at English and move on to the next step. To move on to the second step, you press the extra cycle button, and that pushes the valve into the next setting and saves whatever is selected here. So we will select English to save that and move on to the next step. We will press the extra cycle button, which is the button with the 4 arrows going in a circular fashion. Now, the second step will be setting the system type, which basically distinguishes if you have tanks operating in duplex, twin alternating, or triplex. Now our video or tutorial here will only cover system type, which is unit 4, which represents a single unit. Again, many different types of system types can be used, you know, from 14 to 9 and so on, but we will only cover system 4 for simplicity. So again, system 4 is for a single unit, which is what we will be covering our tutorial on. The third step of the master programming mode will be to determine the regeneration type. Many different types of regeneration types exist. For example, we have a time clock delayed. We have a meter immediate if you have a flow meter installed and connected to the controller, if you want the regeneration to be queued based on the volume of water treated. And the meter delayed, it's important to note that it will queue the regeneration immediately without a delay. So once that capacity has been exhausted, the regeneration's immediately queued. The third setting type for the regeneration type is a meter delay fixed reserve, where essentially once the capacity of the system has been exhausted based on the calculated capacity and the volume treated, you can set a certain capacity in gallons, for example, like 500 gallons. So it'll delay at about 500 gallons until it queues the regeneration, in case you have other systems downstream that cannot really stop the flow of water, and once this capacity has been exhausted. So we will set ours at a time clock delayed because we don't have a flow meter enabled for this part of the tutorial. So for the fourth step of the master programming mode would be setting the valve type. The 3200 NXT controller is installed on many different type of Fleck valves, from a 2850 to a 2750 to a 3900 or a 3150. So for the sake of this tutorial, we're going to keep it set at 2850 because that's just
what this valve in particular is, but again, the 3200 controller is used for many different valves, and this must be set based on the valve type. So once that's been set and configured, we move on to the 5th step, which is setting the regenerant flow. So again, since this is a filter and not a softener, we assume it is a downflow, and that's how this valve has been ordered and configured. So that's very important. So different options exist, but since this is a filter, we'll keep it set at downflow. The remote signal start setting allows for basically an input where you can cue a regeneration. For example, if you have a differential pressure switch or other types of inputs that you would like to cue regeneration based on, that can be set here. So essentially the time is how long you want to wait until this regeneration is cued. So for example, if you have a differential pressure switch and you set this at 2 minutes, once that signal is activated, it will wait 2 minutes, and basically that signal must be held for 2 minutes in order for it to cue a regeneration. It's basically a delay for it to actually regard the input. The next step would be to set the display format in US gallons. Again, this can be set in different types, in liters and gallons and so on. So we keep it set as default, and we program all our valves to be set in US gallons. The next step would be to set the regeneration days override. Now, since we have this set as a time clock, we will set, of course, the time of backwash shortly, but this determines how often or how many days are in between each regeneration. So for example, if we have this set at 7 days, your backwash will occur essentially once a week. So if day number 1 is Sunday and so on, the 7th day of the week will be the regeneration. So of course this can be changed to anything, right? For the sake of this demonstration, we're going to set it at 3, so our valve will backwash every 3 days. And of course this can be configured based on media type, application, and many other parameters that the operator feels must be taken into account. The next step would be setting the regeneration time. Again, this can be set based on many different parameters, just like the regeneration day override. If you have more than one system connected together or operating in series, for example, a multimedia filter, a carbon, and a green sand, you would want to stagger these backwash times so these systems never backwash at the same time. So for example, your media filter would be set at 12 a.m., your carbon at 1 a.m., and your green sand at 2 a.m. That's very important, so you have this kind of staggering setup so you're not backwashing 3 filters at the same time, because that would require much larger backwash systems and can possibly not allow a proper backwash to take place. So for our setting here, we'll just keep it set at 2 a.m. But again, of course, this can be changed to any time that the user feels is appropriate. The next step would be setting the backwash length or duration. So that can be changed, of course, to any setting, but we typically like to set up our filtration systems to be set at 12 minutes of backwash. So the valve will reverse the flow for a length of 12 minutes and basically push all that water to the drain. Next would be setting the brine and slow rinse. So since this is a filter valve, this actually must be set at 0. So cycle 2 brine and slow rinse must be set at 0. So this will just automatically skip this step once the valve is in regeneration and essentially totally ignore cycle 2. Cycle 3 would be setting the rapid rinse. This is where the valve is basically doing a forward flush and diverting the water again to drain. So we typically set our filter valves to 5 minutes which we feel is sufficient to displace the complete volume of water in a filter tank, of course based on the drain line flow control setting. And again, this can be set to any time based on what the user feels appropriate, but we really feel that the 5-minute setting is appropriate. Cycle 4 again is not a setting that's required for a
a media filter. So similar to cycle 2, this can be set to 0 minutes. So we will set this at 0 minutes and move on to the next step. Now, something to point out really here is if this is actually set at a particular time, it's essentially just going to prolong the length of backwash and essentially just have the system offline for a longer period of time, but it's really not going to be doing anything beneficial in terms of regenerating the system, because cycle 4 would be used for a softener or other types of systems. So we'll set it at 0 because that's the correct setting and move on to the next step here. So again, cycle 5 will also be off because that's going to be for a softener. So as shown here, it indicates that it is set as off. The next step of the master programming mode would be to enable or disable an auxiliary relay output. The benefit of this is if you have auxiliary systems downstream or upstream of this valve or filter, you would want to essentially notify the operator or other control panels like a reverse osmosis system that this valve is going into, or this filter is going into regeneration, and the other particular system that it relies on, it must be shut down. So to enable it, you toggle with the up and down arrow. We will enable it, and Pure Aqua enables this on all its systems because we typically connect these or interlock them with reverse osmosis systems, and we don't want any dirty water to enter the reverse osmosis systems while this is regenerating. So again, we enable the auxiliary relay, and from there we basically set what time or at what point of the regeneration we want the relay to energize. So for example, we typically set this at 0 minutes. So right at the start of the regeneration, it will automatically energize that relay and provide that output we need. But if, for example, if the particular application does not require to be notified or shut down a system, during the backwash cycle, you can change the time, for example, to 12 minutes, and that will only energize the output at the 12-minute mark. But again, Pure Aqua sets these at the 0-minute mark, so the relay is energized the entire time. From there, the next step would be setting the auxiliary relay output end, and that determines when you want the relay to de-energize. And again, that is basically the other end of the regeneration. So if you're doing, and you don't want to be notified when a rinse is in process, you can stop this at 12 minutes and so on. And this really is set based on application and auxiliary systems that are installed. But we would set this at 17 minutes. And something important to note is if once this is set at 1 minute, you can use the down arrow to go from backwards basically, and it does the math automatically where it'll add up the rinse and backwash total times. Since we set those at 12 and 5 respectively, we have a total time of 17 minutes, which is shown here. And that completes the master programming mode. And once that's done, you will see a little this display saying saving or configuring valve. And once that setting is done, you're back to the home screen where it says the system 4, and it says the local time, and it indicates that the regeneration is in 3 days. So now the second menu here for programming is the user programming mode. Again, as mentioned, it's much simpler. It's about 3 or 4 steps. And to access that, the user programming mode, you must hold the down and up arrows 5 seconds for 5 seconds simultaneously. And once that's done, the first setting is setting or selecting the language type. Again, you can change that between English, Spanish, or Portuguese, and various other languages. So we'll keep this set at English, and to save that setting, we move forward by pressing the extra cycle button, which is the button with 4 arrows in a circular fashion here. Press that saves and moves on to the next step. Again, the next setting would be setting the regeneration day override, which, as mentioned previously, is basically how many days in between each regeneration or backwash, and that can be set based on application and media type. The next setting would be the regeneration time, which, as mentioned, is what time once the regeneration is queued, at what time of that day the regeneration will begin. So as mentioned, if you have various systems connected together in series, you would want to stagger these times so there's no overlap in backwashes. We keep this set at 2 a.m. for the sake of this tutorial, which is acceptable. To move forward, you press the extra cycle button again, and that would complete the setting of the user programming mode and save all those settings. In this section of the video, we will cover some troubleshooting and diagnostic steps for the Fleck 3150 control valve. We will discuss the error type, the cause, and some diagnostic steps. So it's important to note that it can take the valve up to 30 seconds to detect an error or display that. And all errors on each timer in the system must be displayed before the errors can be corrected. 6 of the most common errors that are found on the Fleck 3200 NXT controller will be discussed as follows. The first will be if there's a matching address error programmed on the valve. The correction for that would be to program the units correctly in the master programming mode and make sure that the matching address is correct. The second error would be a flashing or blinking display, which indicates that a power outage has occurred. If that has occurred and the power is back on, no correction is needed. The third error would be a format mismatch, where different valves connected together have different units, where one valve is in gallons while the other valve is in a metric unit. And the correction for that would be to ensure that all the different valves connected together have the same display format to ensure that they're communicating properly. The fourth error would be where there is no messages displayed and small black squares appear on the display. This can be corrected by changing the display settings in contrast to match and adjust the LCD to the right contrast. The fifth error is a size error, where the units are not correctly numbered and more than one unit has the same number assigned. The correction for that would be checking that each unit is properly configured with the right unit number to make sure that differing valves do not have the same number, as that can cause a communication error between the different controllers. Finally, a communication error is common, and the correction for that would be to check all wiring in the system and verify that it is properly terminated and connected, as that can cause communication errors where wires are not properly stripped or properly connected. With that, that concludes our troubleshooting section for the Fleck 3200 NXT controller. In this section of the video, we will cover maintenance and rebuild kits. Pure Aqua typically recommends replacing certain components every 2 to 3 years to minimize the chances of downtime and potential failure of these valves. Although these valves are reliable, of course, like any pieces of equipment, maintenance is needed. One of the first components we typically recommend getting replaced is the control board here. Now this is of course the heart of the system in a way, as this has all the programming settings and so on. So every 2 to 3 years, this is a very good component or part to replace. Aside from that, we typically like to recommend replacing the motor here and any other moving parts shown here. Now, the manual has very good exploded views of all components with part numbers called out in detail. So aside from replacing certain components, it's also very good to just do visual inspections. There's several connections, of course, here that are made on the valve, so inspecting those connections and making sure there's absolutely no leaks on a weekly or maybe possibly monthly basis is very important to ensure that you minimize corrosion on components around the valve if water is dripping out. Also, the drain line flow control can potentially get certain debris stuck inside. It's important and recommended to take that apart, clean it, install it back together, and reinstall it onto the top of the valve. With that, that concludes our maintenance and rebuild section of the video. This wraps up our Learning Center video, and we thank you for watching.